We can also use the first derivative test at an endpoint. So I just want to go through real quick. A critical point is a point in a function where the derivative equals 0 or the derivative is undefined. We also have potential extrema at the endpoints, so we can use the first derivative at the endpoint also. The only difference here is, since it's at an endpoint, we can't look at the derivative to the left and to the right. We can only look at the derivative on one side. If it's a left endpoint, then we can only look at the derivative to the right of the endpoint. If it's to the right of the endpoint. If it's a right endpoint, we can only look at the derivative to the left of the endpoint. So let's look at what's happening in each one here, and we'll decide what kind of extrema we get. But this is also a justification that you could use using the first derivative test to say an endpoint is a local minimum or local maximum. So if we're at a left endpoint, we have some value here. The function has some value, and the first derivative is positive when x is bigger than a. So we're looking. This is at a comma something, a comma f of a here, and this is our endpoint. So the function is defined just to the right of this. If the first derivative is positive, which way is it going? It's increasing. So is this going to be a minimum or a maximum? It's going to be a minimum. So for a left endpoint, if the function is increasing as it goes to the right, it's going to be a local minimum. Does that make sense? Okay. If the first derivative is negative when x is bigger than a, then what does that mean about that point? So the first derivative is negative, so we start at a point and it's decreasing, so this point here is going to be a local maximum. Now, this is kind of an intuitive idea, but if you have to give an explanation, you have to give calculus reasons. So if you had to justify that an endpoint is a local maximum, you would want to say that the derivative is negative to the right of a, to the right of that endpoint. Okay, and you wouldn't use a, you would use whatever value, whatever that left endpoint is, maybe 3 or -1 or whatever it is. How about with a right endpoint? So with a right endpoint, when x is less than b, the derivative is positive. Is that point going to be a local minimum or local maximum? Oh, my derivative's not positive. There the derivative's positive, right? Because the function's increasing. Has a positive slope. Do you guys agree? Okay. I had that backwards, sorry. So is this going to be a local minimum or a local maximum? That's going to be a local maximum. And if the first derivative is negative for the right endpoint, what's it going to be? That's going to be a minimum. Does that make sense? I don't want to spend a whole lot of time on this. We will look at least one example tomorrow where you'll have to recognize this also. So if we had to justify whether an endpoint is a local minimum or a local maximum, we would use this first derivative test, and we would say that the derivative is positive to the right of the left endpoint or whatever to make our justification. Any questions about that?